This is question number 14 of our calculus review. If f of x is equal to x to the fourth plus 4x, we want to find f prime of x. And then check to see that your answer in part A is reasonable by comparing the graph of f and f prime. So first and foremost, we need to find this derivative. So f prime of x is, by definition, the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And let's do the work for that down here. F of x plus h minus f of x, all divided by h. So this would be x plus h to the fourth plus 4 times x plus h minus, let me fix my h there, minus, this would be, let me just section these off, minus x to the fourth plus 4x, all divided by h. So expanding the x plus h to the fourth, distributing the 4 and the 4 times x plus h, and distributing this negative at the end, this makes x to the fourth plus 4x cubed times h. Let me just fix that to make that more readable. 4x cubed times h plus 6x squared times h squared plus 4x times h cubed plus h to the fourth plus 4x plus 4h minus x to the fourth minus 4x, all divided by h. And a few things cancel there, right? These x to the fourths and the 4x. So this would leave us with, before we divide by h, and this would leave 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth plus 4h, all divided by h. And that leaves us with, when we divide by h, 4x cubed plus 6x squared times h plus 4x times h squared plus h cubed plus 4. So we can rewrite our limit now with this before we apply h is equal to 0. Limit as h approaches 0 of 4x cubed plus 6x squared times h plus 4x h squared plus h cubed plus 4. So since h can be 0 here and make no issues, we would just be left with 4x cubed plus 4. And to compare those graphs, let me pull up Desmos for this. Our original function was x to the fourth plus 4x. And let me zoom out so we could see that. There we go. And the derivative we just found, which was 4x cubed plus 4. And we could see that comparison by looking at this, even though we are not looking at a specific point per se. But the derivative, the one in green, does show that derivative of our original function in red. Thank you.